Okay, so proofs involving parallelograms. Not so much proving that something is a type of parallelogram. This course is not a proof theory course. If it was, we would really be getting into proving a lot of other things. But what I do want to talk about now is applying parallelograms to proofs you're already comfortable with. And before we begin, let's have a little conversation here. One of my favorite verses that I love is, "Come, let us reason well together." Let us do that. Let us reason well together. Here's your strategy. Do not focus on the picture. Otherwise, you will become roadside pizza. Focus on the given. Okay, look at the picture. Great. Move on. Focus on the given. Focus on every single piece of that given and use it to your advantage. Once you use it, mark it as used. Once everything is used, then and only then do you begin to look at the picture and you look for linear pairs. You look for reflexive, you look for vertical angles, and whichever one you find, you use to your advantage. So let's try this one right here. Go ahead, stop and start. Okay. So we pull the given out of the statement above, and the big thing here is it's a rectangle ABCD. It also says that angle ADG is congruent to angle BCG. The reason is because of given. So what does that mean? Well, those are the two angles they're talking about. Angle ADG and angle BCG. All right. So I know they're given. I got that all ready to go. Beautiful. This rectangle thing's a really important deal though, right? What are some of the things that are important about rectangles? Well, one of the things that's important about rectangles is that it's got all right angles. So angle A is going to be congruent to angle B. How come? Because a rectangle has four congruent right angles. So there they are. All right. Now, remember how I said use up all the given, and once you've used it, you can put a check mark and be done with it? But I did say there's an exception. And I said the exception is when you're dealing with something in the given that has more than one property to it, because you might have to use more than one piece of it. And that's the case here with rectangle. What else do you know about rectangle? Well, the other thing that I know about rectangle is I know that the opposite sides are going to be congruent. So AD is going to be congruent to BC because the opposite sides of a rectangle are congruent, and I mark that. And now I can see that the two triangles are congruent by ASA. Now I want you to notice that everything that was just done was done without ever looking at the figure or focusing on the figure. Everything was just applying pieces of the given, pieces of the given. It said rectangle, I used rectangle. It said rectangle, I used rectangle. That's what it was. They gave me the two congruent angles. Now, what's up next? I could say the two triangles are congruent by ASA. At this point, I can see students getting a little bit lost and saying, well, I really don't know how to finish it off. But see, if you do what I mentioned before about taking the given and using the given, using every single piece of the given, you've at least gotten to the point where if this is a 10-point question, you have earned yourself 7 out of 10. So what do they want next? They want this little piece AE congruent to this little piece BF. And I do think this is tricky. Once you see it a couple of times, it's not bad. But this being, I think, only the second time we've seen it, it's a little challenging. But I hope that you can see, well, they're parts of these bigger pieces. So let's say that AF, this bigger piece here, is congruent to BE, the bigger piece here, by CPCTC. If you could only stop there, I would understand that, okay? But there's two more steps to take. The next step that you're going to take is, also I marked that for you so that you can see. Now the next step you're going to take is that EF is congruent to EF. You see how the piece from E to F is a part of both of those blue lines? So for instance, if the distance from A to E was 2 and from E to F was 5, well, by CPCTC, the distance from E to B is also 7, and that piece above EF is also 5. So AE and BF would both have to be 2. So if I take away that EF piece, I'm going to get that AE and BF, both being 2, had to be congruent. But before I do that, I have to say that EF is congruent to EF by reflexive. And that's a little tricky. I honestly don't expect anybody to get that right until you've seen it. Once you've seen it, then it makes sense, okay? EF is congruent to EF by reflexive. Always mark the X there. And then AE is congruent to BF by subtraction. That's a tricky one. And what I would suggest that you do is that you go back and you watch this video again and do the question again a little bit later and see that you can get it right. The 4 that we're doing today are pretty challenging. Okay. Next up. Give it a shot. Go ahead. Okay, using our stop and start that we like to do. I have my given copied down that ACDE is a rectangle and AB is congruent to BC. So I marked AB and BC because they gave it to me. And I also included the angle 1 and angle 2 right there because we're going to use them a little later on. I also want to state that AE is congruent to CD because opposite sides of a rectangle are congruent. Okay, so I got that going on there. I'll mark those. Next up, angle 1 is congruent to angle 2 because perpendicular lines form congruent right angles, and we know that the rectangle has 4 right angles. You could just say that. Either way, they're both good. Step 4, angle 3 is congruent to angle 4. This is a little tricky. What I want you to focus on is this big triangle on the top here, triangle ABC. I know that that's isosceles because AB is congruent to BC. And then the base angles have to be congruent, and that's why 3 is congruent to 4. So in a triangle, the angles opposite congruent sides are congruent. You could have also said base angles of an isosceles triangle are congruent. A little less rigorous, but that's okay. So now, the next step is, now check this out. 1 and 2 are both 90 degrees. And I know that 3 and 4 are both equal. Maybe they're both 30 degrees. The bottom line is that the big angle from E to A to B is going to be congruent to the big angle from D to C to B because of addition. I'm going to add those guys up, right? Like if 1 and 2 are 90 and 3 and 4 are each 30, then the big angle is going to be 120 each. So I added them up. That's the addition postulate. And there's my markings where I added them up. Okay? Well, that makes this triangle on the left, triangle ABE, and triangle CBD congruent by side angle side is congruent to side angle side. See the side there with the mark? I actually should have made 2 marks on one of these two. That's a mistake by me. Side and then the angle and the side. And last but not least, BE is congruent to BD. This stretch right down here by CPCTC. Okay? Notice it was all using the given. You say rectangle, I say rectangle. Boo, yah, boo, yah. And then we say, you say, oh, rectangle perpendicular. We'll use that too. You say rectangle, we say perpendicular. You, yah, you, yah. And then I start thinking, okay, well, now let me look at the figure a little. Oh, look, I got an isosceles triangle because 2 sides are equal, which is still related to the given. And then you've got addition and SAS. Next up. Okay, time for me to put the answers up here. I write down the given. ABCD is a rhombus. And there's nothing else there that's important. So first, in a rhombus, all sides are congruent. So I want to get BE congruent to DE. I want to get this long piece out here congruent to this long piece. And that means I need these triangles on the outside congruent. So the first thing I'm going to say is that, well, you know what? BC and DC are going to have to be congruent because they are consecutive sides of a rhombus. And those are congruent. You say rhombus, I say rhombus. Rhombus, rhombus. How hard is this, right? Next up. And I never thought I'd be a cheerleader as long as I live. I would be like the world's worst cheerleader. Next up, I can say, because it's a rhombus, you say rhombus, I say rhombus, rhombus, rhombus. Next thing we say is, oh, I mark them to be congruent. The next thing I'll say is that angle 1 is congruent to angle 2, because in a rhombus, the diagonal bisects the vertices. So, diagonal of a rhombus bisects the vertices and divides it into 2 congruent angles. You say rhombus, I say rhombus, rhombus, rhombus. See how we do this? This is how we do this with the given. All right, next up, we say, okay, I got those marked. Used up a lot of rhombus here. got to get those 3 and 4 angles. Hey, wait a minute, look. Remember when I said, we haven't used this yet, so this is new, and you should watch this video a second time. 1 and 3 make a linear pair, and 2 and 4 make a linear pair. So angle 1 is supplementary to angle 3. That means 1 and 3 add up to 180, you know that. And 2 and 4 also add up to 180. So if 2 angles form a linear pair, then they are supplementary. Next up, angle 2 is supplementary to angle 4. If 2 angles form a linear pair, then they are supplementary. So all I say is that 1 and 3 are supplementary, 2 and 4 are supplementary. Then I say that 3 is congruent to 4 because supplements of congruent angles are congruent. In other words, 1 and 3 add up to 180, 2 and 4 add up to 180. If 1 is 50 and 2 is 50, then 3 and 4 have to be the same thing. They each have to be 130. As long as 1 and 2 are equal, 3 and 4 have to be equal. So supplements of congruent angles are congruent, and I have those angles congruent. Okay, so I have used up all the given, right? I used up everything I could about a rhombus. Oh, hey, wait a minute. Isn't CE congruent to CE by reflexive? There we go. Mark it. And I've got the 2 triangles are going to be congruent by side, angle, side. You say rhombus, I say rhombus, rhombus, rhombus. Triangle BCE is congruent to triangle DCE by side angle side is congruent to side angle side, and BE is congruent to DE by CPCTC, right? Peanut butter, jelly. Triangles congruent, CPCTC. Always go together. Okay, last one. Okay, give it a shot. I'll put up the given for you. Okay, so I say rhombus, you say rhombus, rhombus, rhombus. I say rhombus, you say rhombus, rhombus, rhombus. It says rhombus. Use that rhombus. Rhombus. Oh, look, I want to get TX congruent to TW. That means I got to get these triangles on the outside equal. But listen, consecutive sides of a rhombus are congruent. So I'm going to go right away and say that ST is congruent to VT by consecutive sides of a rhombus are congruent. You say rhombus, I say rhombus, rhombus, rhombus. How hard is this? You say bisect, I say bisect, bisect, bisect. You say midpoint, I say midpoint, midpoint, midpoint. That's all we got to do. Next up. That's my markings for them being congruent. What I marked here with the angles RVW and RSX, those are the 2 they said were congruent. Now, the next thing I'm going to say is that angle 1 is congruent to angle 2. How do I know that? Because you say rhombus, I say rhombus, rhombus, rhombus. The opposite angles of a rhombus are congruent. So, opposite angles of a rhombus are congruent. Look at it. You say rhombus, I say rhombus, rhombus, rhombus. You say rhombus, I say rhombus, rhombus, rhombus. Now, I have these 2 big angles that are congruent to each other, and then I have these 2 little angles that are congruent to each other. If I subtract them, I get the pieces inside the triangle are congruent to each other. So, angle 3 is going to be congruent to angle 4 by subtraction. Subtraction postulate. If you just wrote subtraction, that's fine too. And then last but not least, now I've used up all the given. I've done my you say rhombus, I say rhombus cheerleading dance. Can you see me in a skirt running around all over the place with all that hairy legs? No, you can't see that. That's terrible. So we've gotten the rhombus used up. We've used up all the cheerleading stuff. But I can say that 3 is congruent to angle 4 by subtraction. And then I look up and I say, where are we at with this diagram? Oh, would you look at that? Those are some of the most beautiful vertical angles I ever saw in my entire life. Oh, c'est magnifique. Angle 5 is congruent to angle 6 by intersecting lines form congruent vertical angles. And then, look, I have my triangles congruent, ASA, the sides between the 2 angles. Triangle VWT is congruent to triangle SXT by ASA is congruent to ASA because the sides between the 2 angles. And last but not least, TX is congruent to TW by CPCTC. Okay, folks. That's all.